Hey everyone, welcome into this next video, this lecture video on the hyperbolic functions. In this video, we would like to compute the derivative with respect to x of the inverse sinh function, or the arcsinh of x function. And we're going to do this one two ways. The first way, we'll just use the formula for arcsinh. So method number one is we recall that the derivative for the arcsinh of x function is that this is the natural log of x plus the square root of x squared plus 1. And now we're just going to very carefully take the derivative of this using chain rule. So the derivative with respect to x of our arcsinh function, right? I'm just going to very carefully work through all the details here, is the derivative of the natural log of x plus the square root x squared plus 1. All right, now the derivative of any log is always u prime over u, right? So it's going to be the derivative of the inside, so x plus square root x squared plus 1, all divided by that same thing, so x plus the square root x squared plus 1. That's the derivative, that's the chain rule, right? U prime over u. And now we need to actually work out the derivative of this top term. So we end up with the derivative of x is just 1. The derivative of a square root is 1 over 2 square roots, but then there's this x squared plus 1 on the inside, so that's another chain rule. So this becomes 2x over 2 square roots of x squared plus 1. And again, it's still all over x plus the square root x squared plus 1. And at this point, we can see we have these 2's that are going to cancel. And we want to add this whole numerator together to get just one term, so we need a common denominator, right? So we're going to treat this 1 like, I'm going to move it just so I have more room. We're going to treat this 1, though, like square root of x squared plus 1 over square root of x squared plus 1, right? And then when we add this up, let's see what we get. We get, obviously, add this straight across the numerator of these two, across the top. So x squared plus 1 plus x divided by, and then what's on the bottom? Well, this is going to be the common denominator on the top itself, and that's going to get joined with the bottom, right? So altogether we get square root of x squared plus 1 times x plus the square root of x squared plus 1. And here we see, at this point, that this term and this term are exactly the same. This term can't be 0, right? It's always bigger, it's always positive, right? So x squared plus 1, if x is 0, then this will be 0. If x is negative, it can approach 0, but that's okay. But this term's always bigger. So the point is that this can be canceled, right? This can be canceled. And what we're left with then is that the derivative of arcsinh is the square root, is 1 over the square root of x squared plus 1. So this is arcsinh of x prime equals 1 over square root x squared plus 1. All right, so that's one way. I said we're going to do this derivative two ways. The other way is to do this similar to the way that we did the arcsine derivative, and that is to remember that arcsinh is the inverse function of sinh, right? So on one hand, we have y equals arcsinh of x. This means, right, it's one-to-one relationship, that sinh of y is equal to x. And now we can take the derivative implicitly of this entire equation, right? This is just like the way we did the derivative of arcsine. So at this point, you have to remember that the y term depends on x. So on the left-hand side, we get a chain rule. Derivative of sinh is cosh times dy dx. That's what we want to find here. That's our goal, right, to compute dy dx. Derivative of x is just 1, right? And so what we have now is that the derivative, dy by dx, is equal to 1 over cosh of y. Now, we can't leave it like this, right? We need to go back and we need to, from this, we need to try to solve for cosh of y by interpreting sinh of y somehow, right? And so for this, we can draw what we call a hyperbolic triangle, and we have to remember the hyperbolic definitions of these functions, or the geometric definitions of these functions, right? So if this is a point on our unit hyperbola, x comma y, then this equation, this triangle has to obey what we call a hyperbolic Pythagorean theorem, and that's that x squared minus y squared equals 1, because this point lies on the unit hyperbola, right? Here's the x, here's the y. So let's draw the hyperbolic triangle that corresponds to sinh of y equals x. So this is just a reminder of the definition of hyperbolic definition of hyperbolic sine. Well, just like in a regular triangle, this y is the angle, right? The x here, the sinh of an angle is equal to the opposite over the hypotenuse in some sense, right? So this is our x, and our hypotenuse is 1. But then this equation has to obey that this squared minus this squared equals 1 squared, right? So again, let's rename these up here so that we don't get confused by the x's and the y's. Let's use a's and b's, and then we can plug in here, right? So ab, this is a, it's got to be b, and then a squared minus b squared is always equal to c squared for hyperbolic triangles. So down here, what are we going to have? We'll have question mark, right? So question mark squared minus x squared equals 1 squared. And so then what do we get? Our question mark is got to be equal to 1 plus x squared square root the whole thing, right? Positive because we're talking lengths. And so this goes in for the adjacent side of our triangle. And so the cosh of y, what do we learn? Cosh of y is exactly adjacent over hypotenuse. It's square root 1 plus x squared over 1. That goes back in up here, right? So dy by dx, which is the derivative with respect to x of our arcsinh function. This is 1 over square root. You can again change the order here if you want, but x squared plus 1 or 1 plus x squared, either way. So either way you do it, that's what you get. All right, now one last thing before we end this video. Whenever you do learn a new derivative, you also, by the fundamental theorem of calculus, you also learn a new antiderivative, right? So we've also learned, just by doing this, right? We've also learned the following, that the integral or antiderivative of the square root of x squared plus 1 dx, this is equal to the arcsinh function of x plus a constant always. All right, so one of the goals in Calc 2 is to learn how to compute as many antiderivatives as possible. And so whenever we learn a new derivative, we also learn a new antiderivative, and that's where we're going to go with these, all right? So at this point, you should be able to compute the derivatives of arccosh and arctangent. All right, so now this is for you guys, for the students. Compute the derivatives at this point of arctangent of x. You can use either method. Why don't you do one each way, just so you make sure you get both methods down. And also arccosh of x. And then also write down the corresponding antiderivatives that you get from those. All right, I'll see you guys in the next video.